Minimum audible angle, smallest angle between two distinguishable sound sources in the horizontal plane. Best accuracy below 1000 Hz and straight ahead. 1 to 2 degrees corresponds to ICDs of approximately 10 to 20 milliseconds. So on the curve here we have the frequency on the first axis and minimum audible angle on the second axis. We see with no degrees azimuth just in front, you have smaller audible angles than if you have a 30 degrees azimuth. Especially for at below 1000 Hz, it's 0 degrees and 30 degrees azimuth are almost similar low minimum audible angles. Yeah, about 1 to 2 degrees. Summary ITD and ILD. Horizontal plane localization using two main cues, ITD and ILD. Inter-oral time difference, ITD. Difference in arrival time at both ears. Dominant cue at low frequencies less than 1500 Hz. Envelope ITD information available at higher frequencies. Envelope ITD information available at higher frequencies. Then we have the inter-oral level difference. ILD is difference in level at both ears. Dominant cue at high frequencies. ILDs are small at low frequencies. ILDs are small at low frequency because there's a lot of diffraction. So the ILD is the difference is small because of the big diffraction. At higher frequencies, there's a smaller diffraction, then a bigger level difference. How do ICD and ILD cues compare between two loudspeakers? Same ITD and ILD. What will you do? We have this cone of confusion. All localization, you have a tract, for instance, left or right here. All localizations on the surface of cone produce the same ITD ILD cues. All locations on the surface of cone produce the same ITD ILD cues. But we can distinguish between these points. Implies additional mechanics and or cues. So yeah. So if we as solution head movement, we have ambiguities resolved by head movement in intersection of two cones of confusion. Okay. So if you have a sound source in front of you and you are just ITD is 0 at left and right ear. ITD, same time, no time difference. But if you are moving your head, you, for instance, the left ear is nearer the loudspeaker, then you will hear better on the left. Yeah. Okay. Now you have a median plan in the middle. Let's just go middle of up down straight through your head, up down. Yeah. It's not the same as a frontal, but a median plan. Yeah. Okay. And we have median plan. We have a median plan and frontal plan and horizontal plan. Limitations of ITD-ILD approach. ITD and ILD cues are good cues for locating sources on the horizontal plane, but they are insufficient for judging whether a sound is located in the front or in the back, or above or below. Yeah, yes. Cone of confusion. ITD and ILD cues visually identical for sources located at an equal distance on cone of confusion. Human sound localizations. Humans are good, and you are good at localization for any point in space. New model. Two approaches to extend our understanding. Psychophysical approach. There must be extra cues that are processed by the human hearing system. Here, engineering approach. We need a better tool model than ITD-ILD to describe spatial hearing without ambiguity for any points of space. Yeah. Okay. I don't know what to say about this. Correlation between boosted and directional bands. New spatial cue. Directional bands. It could be top, back, front, and yeah. Okay. New spatial cue, spectral cue. Acoustic wave filtered by the listener's head, torso, and the pinna. Filtering is directionally dependent on and unique for each spatial position, asymmetric shape of our head or torso. Auditory system can infer localization from spectral information. Filtering can be measured and expressed as a transfer function. Okay, head-related transfer function. HRTF in horizontal plane. Yeah, and what are the ITDs and ILD? ILD are frequency dependent. Yeah, okay. You have some impulse response. Okay, magnitude spectrum for ITD and ILD. ILDs are frequent dependent. Yeah, bigger ILDs at higher, bigger ILDs with higher frequencies. Yeah, not the same for ITD. Okay. A bit summary: 3 sets of cues: ITDs, ILDs, spectral filtering from head, torso, or pinna. Combined, these cues are sufficient to resolve all angles in horizontal and median plane. Okay. Three cues are all included in head-related transfer function. Transfer functions between each point of space and the ears of the listener. HRTFs are unique for each point of space, each listener, and each ear. Okay. Transfer functions between each point of space and the ears of the listener. Okay. A little bit difficult. Intensity decreased with increasing distance. For omnisource in the free field, source is only dependent of the radius distance. P, the power is inverse proportional proportional to the distance r. Requires familiarity with sound with source signals. Vocal and thoughts question, what about in the rooms? Oh. Direct to reverberant energy ratio. In rooms, direct sound is followed by reflections. Direct to reverberant energy ratios varies with distance. Closer means more direct sound, further away, less direct sounds. Q depend on the room size, shape, and materials. Only exist in reverberant environments. Spectral changes. Long distances, more than 15 meters. Frequency-dependent attenuation in air, high frequencies attenuated more than low. Okay. Far sounds contain less high frequencies energy, that means low energy rumble of far thunder. Reverberation can also spectrally color sound. Shorter distances, less than less than a half meter, waves are no longer planar but spherical. HRTF becomes distance-dependent, monaural and interaural changes. Sound sources close to 1 year, very large ILD. Okay. Sound source close to 1 year, very large ILD. Yes. Bias judgments overestimate distance for close sources, underestimate distance for sources far away. Summary. Definitions: monaural, binaural, dichotic. HRTF are integral and code all spatial locations. Duplex theory: ILD at low frequency, ITD at low frequency, ILD at high frequency, as before. Precedence effect: law of the first wavefront. Distance perception. Intensity direct to reverberant ratio. Ambisonics, spherical harmonics. Headphone reduction with HRTF. Cone of confusion, minimal audible angle, and so on. A lot of things here. Okay, I take the summary here for sense of hearing. There are several different types of information about sound source location available to the auditory system, and it happens that our brain combines these, and it appears that our brains combine these different cues. Interaural time and level differences provide detailed information about the direction of a sound source, but this information is ambiguous and accurate localization depends on the use of other types of information, such as the effects of head movements and the localization-dependent modifications of the pinna. Our appreciation of the acoustic space around us is dependent on information about source location and the information about the reflective surfaces and the characteristics of reverberation. Having our 2 ears help us determine the direction of a sound source. There are 2 such binaural cues. Interaural time differences. Sound from the right arrives at right first, and interaural level difference. Sound from the right is more intensive in the right ear. Interaural time differences are dominant for most interaural differences are dominant for most interaural sounds, and there are some things more. Okay, that was part 2.